All right. Maybe we should start again. Now it's time to enter the technical matters after data, physics, and measurements. I leave ground to engineer Andrea Sangalli from Politecnico di Milano for his presentation. Andrea, would you stand or sit? Okay, this is the clicker. I guess it works. Okay. Yes.
Thank you, Federico. I'm Andrea Sangalli, building engineer and senior laboratory technician at Politecnico di Milano. And I will present the results of a collaboration since more than 10 years ago with the Comune di Milano, the city of Milan, in particular with the technicians, the architects Silvia Bardeschi and Fabrizio Manzoni, by which we are making possible to enable the concept of building as battery that has been already introduced in the speeches before. So the main point that we would like to highlight in this session is that building as battery, it's a concept that can be enabled and exploited with sensor, with algorithms, like we are doing in the SATO project, but there is a precondition, a necessary condition, in order to make this potential available. That is the quality of the envelope, the quality of the thermal envelope of the building. Because you can have all the sensor, all the algorithms, but if you don't have the potential given by the physics, by the good physics of the building, you don't have much to optimize. So that's why we wanted to focus a particular part of this session on this topic. And in particular, the level of insulation plays a crucial role in the exploitation of the building as battery concept. And even more, it has been proved in the scientific literature, more than the type of heat emitters, like the mechanical systems, and also the presence of additional indoor thermal mass. And it's also important to highlight that the cost of this thermal mass is already offset by the energy saving obtained during the life cycle of the building. So we don't require much additional investment, like it's, on the other hand, required for other kind of energy flexibility with different kind of energy storage, like, for example, the classical electrical storage. So it's just necessary to make an additional investment in monitoring and control systems and algorithms that is for sure quite lower than an additional investment in terms of other kind of facilities in the building. That's why we wanted to show a particular case study. So it's not something particularly innovative from the point of view of the scientific literature. It's something that is already well known, but it's something good in terms and with a novelty in terms of implementation, especially in the framework and the context of the public administration, like, for example, of Comune di Milano. This was actually the first building of public residential kind that was done by NZEB, or nearly zero energy concept, for the municipality of Milan. As a location, we are in the outskirts of the southeast of Milan. It's still Milan, it's a neighbor of Milan, but it's a kind of village, historical neighborhood, in which there has been implemented since 2013 several European projects to improve this neighborhood to the smart city, smart neighbor concept, and to the nearly zero energy building concept. We started with the San Bernardo 4850 with the UGoogle FP7 project from 2013 to 2019. And then in the San Bernardo 29, that is the one that I will address in this speech, it started with the refurbishment works in the Sharing Cities project, and then we continued with the SATO project exactly to optimize the good work that had been done previously in terms of thermal envelope and building physics to add high-quality algorithms and controls that has been developed inside the SATO project. Just to go quickly, this is the overview of the complex. It's 2 buildings of 4 floors and around 4,000 net floor area in total. And as I said, is a public residential building, so with the reduced rent for low-income families. Just to have an overview of the existing situation, in the pre-retrofit situation, these are buildings from the 80s of the previous century, built with the particular, for that area, technique of prefabricated concrete elements in the facade, in which there was basically no insulation. So there was a good thermal mass, but there was not at all almost insulation. There was some problems of surface condensation leading to mold growth inside many apartments due to, of course, the thermal bridges that were relevant, and no external insulation that has been added at a later stage during the works. This is a comparison between the main values related to the envelope before the renovation and after. You can just take a look, for example, at the first one for the thermal transmittance of the opaque structures. We start from 1.15 of thermal transmittance to 0.13, so a reduction of 1 order of magnitude. And the same also for other parameters that has been shown here. Another important aspect that has been introduced is mechanical ventilation with heat recovery, that together with the quality of the envelope leads to a very good reduction in terms of energy needs. So this concept, energy need, has a specific technical meaning also in the international and European standards, and it's exactly the energy, thermal energy, that is physically necessary to provide to a conditional space to keep a certain temperature, typically 20 degrees in winter and 26 in summer. So this value doesn't have anything to do with the mechanical systems. It doesn't have anything to do with the efficiency of the mechanical system. No, it's exactly the energy that must provided by the mechanical systems. Then the energy that we have to give to the mechanical system would be a bit higher, depending on the efficiency of the mechanical system, heating and cooling systems. So we want to focus on the basis of the energy concept, so the energy needs that, as it is explained in the most advanced building standard, like also the Passive House standard or Casa Clima in Italy, the logical path that must be done is start to strong reduction of energy needs, then providing this energy with efficient mechanical systems, and last step, providing as much of this energy to the mechanical system with renewable energy sources. To go further in detail about the thermal envelope, as already been mentioned by Professor Pagliano, we added these 24 centimeters, 24, 25, depending on the facades, of external coating insulation to really make it possible to exploit at a later stage this very good thermal mass that remains on the warm side of the envelope. As you can see, there has been different kind of thermal insulation materials depending on the different surfaces. Basically, depending on the thickness that was available. Typically, on the balcony, there is the problems of limited space, so we have to introduce materials with a lower thermal conductivity to get the same performance with the less thickness of the material. So again, in collaboration between the architects that were the leaders of the project and us as a support for the scientific and thermal analysis, we had also this study of different materials that could be installed in the different part of the walls. and using also aerogel, phenolic resin, depending on the situation. And the project has been completed with mosquito nets, because it's an area where this is a relevant issue, to allow for natural ventilation. So another further decrease of energy need for cooling during the summer season, as it is provided by the most advanced thermal standards in the topic of comfort, like ASHRAE 2020, ASHRAE 55 2023. Regarding thermal bridge, especially particular work has been done to identify all of them with a finite element analysis in order to reduce as much as possible each of the thermal bridge. For example, here in this ground floor that is not heated is on columns. It has been added an additional part of insulation to reduce the thermal bridge from the ground level to the first level of the building. Just to make an example, then all the details have been studied and solved as much as possible, one by one. So this was regarding the opaque envelope. Continuing on the other side, that is the transparent envelope. There were these very low quality existing windows with U value of around 4 that we brought to 1.25, and especially with the particular work about air tightness. That is very important to reduce not only the heat transfer, the heat losses by transmission, but also the heat losses by ventilation. And this has been proved at a later stage, as was foreseen by the project, with the blower door test to guarantee that the expected air tightness of the envelope was reached, and it was demonstrated that this was the case. Again, to reduce as much as possible the thermal bridges, also for improving the facility of the easiest of installation, there was it was studied this box with windows with insulation Venetian blinds. So it was just a complete box, including also the solar protections to reduce the thermal bridges between the wall and the window part. And finally, in terms of mechanical ventilation, there was this mechanical ventilation with heat recovery and also bypass for the summer season that was included on the existing, because before there was not any mechanical ventilation, there was just the extraction ventilation from the bathrooms, from the toilets and from the kitchens. There was introduced the inlet mechanical ventilation on the facade. There was also a topic about historical preservation and conservation on that historical area. So this was approved by the local entities in order to have this duct on the external facade, providing fresh and clean air at a very low velocity to not create problems to the users, but with this heat recovery of about 90%, even more of heat recovery. This is another picture of this system in the attic, not heated attic of the building. And there on the right, you can see a picture of the system during the installation. Now, going to the other part, just to give you a complete idea, even though it's not anymore related to the envelope, for the mechanical system, it was installed a heat pump, complementing the existing condensing gas boiler, providing energy for the heating and for domestic hot water. And in terms of energy, renewable energy production, there was installed solar panels and photovoltaic panels. Here you can see the photovoltaic panels with a total of 19 kilowatt peak. And also inside the previous Sharing Cities project, one of the goals was to install also an electric storage for demonstration purposes. So it was these 20 kilowatt hours controlled by the energy management system, feeding the centralized mechanical systems and the common parts of the building. This is a final general overview and summary of the intervention that I've been explaining. And in particular now, we want to focus on the last part that is strictly related to the SATO project. That is the implementation of energy and comfort monitoring, because actually the project at the end, the works obtained very good performances that has been also demonstrated by our monitoring. But actually it was not so easy also due to the construction phase, due to the selection issues of good quality companies in the frameworks of public procurement. In Italy, at least, is like this. It's very difficult to have the warranty that the company that has been selected in the public procurement process will be with a good quality. So at first it was not the case, so the process has not been so straightforward as it should have been, but at the end we got there, and especially thanks to SATO project, we completed and improved the energy comfort monitoring, also introducing some controls. This has been already shown before by Professor Pagliano, so we were doing some environmental monitoring of air temperature, relative humidity, or CO2 in each, at least with one sensor in each apartment or two sensors in big apartments, to have always on the cloud platform from remote a real-time picture of the quality of the envelope, and both from the point of view of the thermal comfort and indoor air quality, so indoor environmental quality. There was also a thermal energy monitoring in all apartments, both for energy use for heating and for domestic hot waters, with a data aggregator that has been connected to SATO. With this regard, there was, of course, different languages that has been implemented in the project, due also to the difficulties that I have mentioned. So it was necessary to make a real system integration, also from the point of view of data acquisition from SATO. Related to the technical room, the centralized heating production for heating and domestic hot water, we had this monitoring, detailed monitoring of many parts of the heating center to have feedback about also the efficiency of generation and distribution of each part of the centralized system. This is just a more detailed scheme of the same concept. And finally, in the framework of SATO and with thanks to the good collaboration with the City of Milan, we had the chance to use one of these unoccupied apartments. And by the way, I forgot to mention that all of the works has been performed without the occupants leaving the building, because there were intervention mostly on the facade, apart from for the domestic hot water that was decentralized and then was changed into centralized, but not much works inside the buildings. There were, though, some apartments not occupied, and one of these has been used by us as a laboratory to test some concept, like the building as battery that we are mentioning, a natural ventilation concept for summers, also related to the flexibility during the warm season. Here, I just want to show you a couple of sensors that we have installed, just more than a couple, actually. We have some surface temperature sensor to allow us to check also what's happening on the thermal mass surrounding our environment, and also to calculate the operative temperature using the mean radiant temperature. We have globothermometers, basically for a similar concept, for a similar reason, to calculate at the end the operative temperature, that is actually what is felt by the human body, and it's important parameters in terms of comfort, thermal comfort assessment. We have also some anemometers mostly related to the natural ventilation experiments, and some of these steel cylinders that are, according to the scientific literature and practice, they are used to simulate indoor internal loads, like people. So they contain like a 100 watt light bulb, exactly producing more or less 100 watt of thermal power. That is what is emitted by the human body. And then we had also some controls that we have integrated in SATO based on the Shelly application, also to make it easy to implement also and deploy on a large scale, since they are low-cost devices and also quite easy to program. And we have installed the motorized windows and motorized Venetian blinds. So everything together creates a framework, a structure that allows us, via the SATO controls, to implement and test different strategies and monitor the effect. Yes, as has been shown already before, this is like a plan of the distribution of the different systems inside the apartment. So that's it from my side.
Thank you very much, Andrea. And now is Francesco Cavicchioli, Dr. Francesco Cavicchioli from Knauf Insulation, that will show us, of course, what's the industry point of view. Please, Francesco.
Yeah, I just add one thing. I forgot to mention that some of the experiment we have done in this test building has been done also in the framework of a collaboration exactly with the Knauf Insulation at first, that then has continued inside the SATO project.
Here something has gone wrong, but
I have 15 minutes. Oh, something happened. Okay.
But it's,
No
I think it's just the first slide.
I can survive.
Hopefully, yeah.
I can survive with it. Good morning, everyone. My name is Francesco. I come from Italy. You should know that tomorrow another Francesco from Italy is supposed to come to Luxembourg. It's more relevant than me, clearly. I prepared that one since a couple of days. Now, representing Knauf Insulation Italy, the Italian branch of Knauf Insulation, here, let's say, part of the SATO consortium, thanks to the involvement of Politecnico of Milan, Lorenzo, and his team. We have worked during the last 4 years trying to provide our contribution to the project. Today, I decided to take a different angle, trying to provide our point of view, leaving the technical and scientific stuff to Lorenzo and Andrea, and trying to provide a different angle from our perspective. Very quickly, I guess, no need to spend much time presenting the group. We are one of the largest manufacturers of system solutions for the building construction all around the world, with the German roots, so nice choice of the room. We are in the German room, so we are honored of that. And Knauf Insulation is part of this big group. Clearly, we are a small part of the biggest family, Knauf family. Anyway, we are still a leader in the insulation manufacturer environment. The figures not easy to be read. I don't know what happened with the PowerPoint. Anyway, again, local European roots, but then plants all over the world, in US, Malaysia, Abu Dhabi, and so on. What we do in Knauf Insulation, we are a proud manufacturer mainly of mineral wool insulation, so rock mineral wool and glass mineral wool. Still few plants in Europe manufacturing wood wool. Why I said proud manufacturer of mineral wool? Because we strongly believe that it's hard to find insulation that is able to combine together energy efficiency, which is quite obvious. Insulation, thermal insulation should provide energy efficiency, but at the same time, mineral wool insulation is able to provide also fire safety to the building occupants, acoustics, and more in general, health and comfort, which I guess has been the reason behind the choice of insulation in the buildings that have been shown by Andrea. By the way, mineral wool insulation could be used in a wide range of application, not only construction, but also to provide green solutions, meaning green roofs, green walls, and so on. It is largely used in the agricultural business as well. Industrial products, most of our kitchen oven are insulated with our products, and then a lot of application in the more wide industry applications. During the 4 years in SATO, together with Politecnico, we stressed on the need of focusing first, let's say, focusing on the energy efficiency first principle. So let's make sure that the building envelope is well insulated, deeply insulated. This will allow a dramatic decrease of the energy demand for heating and cooling, and as shown by Lorenzo and Andrea, together with this benefit, we also have let's say the potential of increasing the number of hours. We have seen even days in which the occupants could stay in a comfort zone, so up to 4 or 5 days. And at the same time, we know that insulation is key also because looking at energy retrofitting of existing building, which is, by the way, the focus of the next 15, 20, 30 years, at least for the European environment. We have a huge amount of buildings which are dramatically energy inefficient. So Green Deal, renovation wave, we all know that we should act now. The idea of my presentation is, okay, let's keep energy efficiency first principle, energy efficiency more in general as a guiding principle. But then, as a manufacturer, we cannot forget our homeworks when it comes to decarbonization. So when I've been asked to provide the industry point of view, I thought it could be interesting also providing that perspective, which is, by the way, one of the 4 pillars of our sustainability strategy as a Knauf Insulation Group, Achieve Zero Carbon. We have 4 main pillars. One of these is Achieve Zero Carbon. The purpose, let's say the target is to minimize the impact of our products and clearly of our plants, very much correlated, by reducing by 2025 15% of our CO2 embodied into our products, and by 25% the CO2 emitted by our facilities, so offices, and clearly very much related with the people, thousands of people traveling all around Europe and the world, actually trying to reduce the impact of what we do on a daily basis. The pressure on the manufacturer to reduce our carbon footprint is more evident than ever. I don't need to, let's say, share with you the reasons behind. I guess all the people in the room, let's say, has the evidence in mind why we need to act now. We have seen this dramatic increase in the average Earth temperature during the last 1.5 century, let's say. So the pressure is there. The pressure is there even though the regulations around Europe are not still there yet. I mean, we see that in some markets, some countries, regulations are already there, asking for low carbon products and so on. But for sure, it is something that we cannot avoid. I mean, regulations will come, so we need to anticipate as much as possible let's say the risk related to the regulation. At some point, it will be a matter of let's say license to operate for manufacturers. No chances to escape. But again, a second source of pressure for manufacturers, the market. We see more and more from voluntary certification schemes like the one that I've mentioned, LEED, BREEAM, WELL. I could list a number of them. But anyway, an increasing demand of low carbon solutions, maybe at building level, but also at product or system level. And at the same time, when we look at our customers, especially the biggest one, since we are part of their scope 3 targets reduction in terms of CO2, they look at us and say, hey guys, please support me in decreasing and achieving my targets in terms of CO2 reduction. Third source of pressure for each of us is clearly competition. Our competitors are there, luckily. They are not waiting for us. We need to act. We cannot just see what they are doing and react. We need to anticipate. So, as insulation manufacturers, we are seated somehow in a good position. The good news for us is that insulation is key when it comes to decarbonization. Why? I don't need to repeat what Andrea and Lorenzo have said, but anyway, insulation, by reducing energy need for heating and cooling, automatically, dramatically decreases the operational carbon. So the CO2 emissions related to heating and cooling the building is, let's say, strongly decreased thanks to a more efficient envelope, which is, by the way, related to a well-insulated envelope. Another good news for us is that the carbon payback, average carbon payback of our products, so the time needed to compensate the emissions related to the manufacture of our solutions is 95 days. So let's imagine to install our products the 1st of January after something more than 3 months, or let's say 3 months. We have compensated the CO2 emissions generated by our plants thanks to the decrease in the operational carbon at the building level. For the remaining 270 days, as an average, we, let's say, provide a relevant contribution to the decrease of carbon emissions. Is it enough? No, for sure it's not enough. We need to hardly work to decrease those 95 days. It's clear focus for us. We need to walk the talk and reduce our carbon footprint. As said, German group, so they love figures, providing clear data, targets, strategy, roadmaps, milestones, and so on. So this is the Knauf Group mid and long-term goals in terms of zero carbon, split by type of emissions, so Scope 1, Scope 2, and Scope 3. By 2032, we are committed to reduce 50% of Scope 1 and Scope 2 combined emissions, and 30% less of Scope 3 related emissions, with the long-term target of being net zero by 2045 on the all three scopes, which is clearly fully aligned with our own as Knauf Insulation strategy, which clearly follows the same milestones. By the way, 2032 is not by chance. It is the 100 years from the foundation of the group. It's not by chance that we decided to take 2032. How's the situation? Looking at our own, let's say, garden in Knauf Insulation, this is the split of our emissions, Scope 1, Scope 2, and Scope 3. I don't have the time to go deep into the details. Anyway, Scope 1, direct emissions, so the ones related with the facilities into our plants or the lines that are burning. We know that we are an energy-intensive sector, industry, so most of our emissions come from Scope 1. Then another relevant, let's say, share of our emission is related to Scope 3, so indirect emissions, inbound and outbound, 42%, and then still relevant, more than 12% from Scope 2, which is, again, indirect emissions, mainly related with purchased electricity or steam. So, clear focus on addressing scope 1 and scope 3, which are, by the way, the most hard to address. So we will need to take some time, but for sure the focus is there. The challenge, what about the challenge? The challenge, as I said, is to make half of our emissions by 2032, which is already quite interesting, and go as close as possible to zero by 2045, absolute values. If we combine those absolute values with the ambition of the group of growing, so increasing the capacity, and it makes sense. I mean, if we have to achieve the European targets of being neutral carbon on the civil sector, so buildings, by 2050, we will need insulation. We will need all the technologies, so photovoltaics, heat pumps, anything that could provide the benefit at building level. But anyway, insulation, we know that will be key. So if we combine reduction targets and ambition growth, the challenge is even more relevant. Where we stand today, last minutes, this is the situation. If we take baseline 20, I forgot the figures that you have seen before, decrease of CO2 emission, baseline 2021. So again, baseline 2021, this is the split of Knauf insulation, EMEA emissions, and then you can see the development towards 2023. Let's say gray one, is it working? Yes. Gray, I can't see it, but anyway, gray one is, no, I wanted to use the indicator, but no problem. Gray one, minus almost 17% global CO2 reductions, and then the split blue, green, orange, or yellow, I don't know, the three scopes. So, what to say? Minus 17% in general, guys, good job. And you can see that mainly coming from scope 2. As usual, we go for the low-hanging fruits, so the easiest, the fastest, let's go on that, and then in the meantime, let's work on the hardest one. The slide says we still have a long way to go. Why? Because it's clear that we have not done enough on scope 3 and scope 1, which is, as I said, the hardest one, the focus of the next 10, 15, 20 years for the group. As said, scope 2, we have as a main contributor so far electricity from renewable sources. Since 2022, in many plants across Europe and also in Malaysia, we have procured, let's say, energy attribute certificates in order to purchase green electricity for those plants. We are launching a pilot project in Croatia, in our rock mineral plant in Croatia, Novi Marof, a power purchase agreement, so long-term, at least 10 years of agreement to get electricity from renewable sources, which will allow us to have our very first full electrical line of manufacturing rock mineral wool products, with the target of being in 2032 fully supplied by low carbon sources when it comes to electricity. Scope 1, which is, as we said, the hardest one, what we are looking at in terms of potential, let's say, solutions to decrease the carbon footprint of our lines. I just brought here 3 examples on which we are working. First one, biomethane. Second one, hydrogen. And third one, potentially as a combination of the 3 carbon capture, use, or storage technologies. Just 3 examples. As I am saying in my last slide, we are sure it's clear that there's no magic solution when it comes to decarbonizing our lines. Most probably, it will be the optimized combination of different technologies, different solutions, different projects for each and every part of our company, also depending on the location of the plant, the energy mix. So there's a lot of, let's say, factors that have to enter into the algorithm, and then we will provide the targets on which we have committed. That's it from my side. Thank you.
Thank you, Francesco. You look like being the right man in the right place in the right time about insulation. So thank you. Next now is the point of view of the city of Milan, which I kindly ask to join me. Okay, thank you very much. Sì. Sì.
Good morning, everyone. My name is Marco Mazziotti. I'm in charge of all the EU projects department at the City of Milano. We coordinate the participation of the municipality in EU funding, together, of course, with the technical colleagues, technical departments. So we actually look for fundings, look for calls, and then we develop with our colleagues and with our partners, both international, local, and Italian partners. Today I'm going to, we have talked long about SATO project, which is a project of City of Milano in partnership with the Politecnico of Milano. SATO project is just one of the projects we are developing with the Politecnico of Milano. And it's just one of them focusing on housing. I'm going now to take a step behind and showcase a few projects the municipality is developing and developed in the past years on this topic. So the backstory, how Comune di Milano went after EU fundings on energy saving in public buildings. It's actually, now we can say, a long story. It's a high priority for the municipality. Today is among the highest public building, but also private building, of course. It is tied to the topic of climate change, of course. The City of Milano here, I forgot to mention, is part of the European initiative 100 Climate Resilient Cities by 2030. And in a couple of days, we are going to have a huge presentation of this initiative in Milano. We defined years ago a municipal strategy for a smart city district in a part of the city, southeast part of the city, called Porta Romana Vettabbia area. And we decided to dedicate, to focus all our projects on this topic, on that district. Today, we are in the second phase of this. So we are working in the entire city, but that was our first experiment. We established partnership at the local level with Politecnico since autumn 2011. So it's almost 13 years and it's still ongoing. It's a profitable partnership. Our technicians need to be trained by academia, and Politecnico is giving us what we need actually and what is missing at municipality level. Then this is our strategy on public buildings, is part of the master plan that led to take part to the C40 network. It's an international network of big cities committed on the fight against climate change, and the Eurocities, which is a European network. And all this gave us the opportunity also to develop the Air and Climate Plan, design the Air and Climate Plan, which is now active in the City of Milano. Very first project, it was mentioned by Andrea probably before, a Google project. Period 2013, it lasted 6 years. You all know how EU projects work. If the project started in 2013, it was taught probably 2 years before. So we can say that maybe in 13 years ago, the municipality of Milano, together with Politecnico, were really thinking about working on this topic. In that period, I was not even working for the municipality. So it was a kind of, Milano was on the front line on this topic, at least compared to other Italian cities. Project EU Google, showcases of cost-efficient urban zero-carbon building renovation models in 6 partner cities and 3 associated cities. The leader was Zavala. The partners which were pilots have been developed were Milano, Gothenburg, Aachen, Bratislava, Sestao, Tampere, and the city of Vienna. These were the main partners. The total partners of the project were 23, with a total budget of 26 million euro. Probably at the end was 30 million euro. Among them, more than half was EU contribution. In Google, we developed an interdisciplinary approach, innovative and cost-efficient mix of actions, a set of sustainability-oriented solutions. We renovated in Europe more than 180,000 square meters of living space, and this was a role model for other cities interested in resilient urban planning. In that period, thanks to a Google project, the Municipality of Milano set the Office for Energy Efficiency, established in the technical department. This was actually the very first lesson learned by an European project. Today, we still have this office composed by colleagues dedicated to work on energy efficiency. These colleagues are also working on other EU projects. This was a 7th framework program, so today we have Horizon Europe, we had Horizon 2020, so you can imagine how all this project. And we can say was among our flagship projects. What was done, really briefly, in energy retrofit of a building with 153 apartments, with approximately 500 inhabitants from 37 different nationalities. First step, envelope renovation and removal of asbestos, 2008, you can see the pictures. 6 years later, second step, installation of heat recovery system, heat pump and panels. Just would like to point out that, as said, 500 inhabitants of 37 different nationalities. Because in these projects, we work on public housing. And we also know there is an issue connected to the topic of energy poverty. On the other side, while we are working on under the technical aspect, so energy retrofit, on the other side, we try to involve citizens and we try to develop other projects, social projects on energy poverty. So we are trying to working from both sides, technical and social. Second project, sharing cities. So let's go to the second programming period, Horizon 2020. This was a huge project, a flagship European project. It was defined. The leader was GLA, the Greater London Authority, the City of London, from 2015, 6 years, 2021. It had maybe 20 partners. The pilots were, the main partners were Milan, Lisbon, and Eurocities. Sharing cities, if we compare with Google was more facing the technical issues on energy, on public housing and retrofit. Sharing cities addresses some of the most pressing urban challenges facing, such as energy use, low carbon transport and buildings, and harnessing data for the good of city. So the main focus of sharing cities were 3: public buildings, energy, mobility, and data. So proven the potential for environmentally focused technology to positively impact cities. We tested the 10 different technologies to reduce carbon emissions, improve energy efficiency, and encourage people, citizens, to make sustainable choices resulted in a reduction of CO2 and greenhouse gas emissions. So under the topic of the mobility, we involved the citizens and supported them and involved them to change their, to make sustainable choices in their daily routine. In addition to drawing on 4 million euro in seed funding from European Commissions, we generated 265 million euro in further investment in the smart city marketplace. This was probably the most difficult target of the entire project, which was successfully reached. We test new technologies. Well, they were new at that time. I guess now are actually not new anymore. The technologies tested by our cities were planned around the needs of people with sustainable behaviors incentivized through rewards. We developed an app where citizens could share what we're doing, how they change their behavior, and they managed to get some rewards as well. We established partnership between city municipalities, private industry, and academia, and this helped to build a strong network of youth cities working together to tackle the climate emergency. This was actually a really tough project to develop because topics were really tough, and that time was actually a really innovative project, but it was at the end quite successful, and it was also recognized by the European Commission. What was done? A dashboard for sustainable energy management, requalification of public residential building, and a series of private residential buildings. So we worked on private building, renovating 5,000 square meters, and we supported the private residential buildings, giving them kind of financial support for 21,000 square meters. We had also intelligent light poles in the demonstration area, capable of guaranteeing control of the lightning flow, depending on the presence of vehicles and pedestrians, in order to reduce energy consumptions. We had a district heating network from renewable energy sources, and we expanded our car sharing and electric bike sharing by creating new charging points and 14 new bike sharings and 150 e-bikes. These bikes are still today used by citizens. Last but not least, the business models to promote smart technologies and their application was also developed. On the right, you just can see one picture of one of the building target of the project. We have a SATO project, of course. Colleagues, people before said enough about this project. You know everything. The platform of SATO integrates all energy-consuming equipment and devices. Project started in 2020 is actually ongoing, even though it's actually at the end. Last month of activities. We are 16 total partners. The budget is 7 million. Among them, almost 6 million is a contribution from European Union. I'm not going to say more about SATO because colleagues said enough. Via San Bernardo 29, which is still the district that we mentioned at the beginning, in southeast area of the city of Milano. We have this residential multi-apartment, public house, 2 buildings of public housing, 66 apartments, and we are working closely with the Politecnico of Milano and other partners to develop and conduct this residential multi-apartment pilot. Another project ongoing in which we are working with the Politecnico of Milano is the Reskin project. This just started last year, ongoing. The Politecnico of Milano is the leader of the project. 21 partners, 10 countries, 4 demo sites. Milano is one of them. The project aims to develop a package capable of transforming an existing energy-intensive building into a modern, efficient, and above all sustainable structure, integrating ICT, renewable energy, sustainable materials, and new generation installations. The Reskin project offers a holistic and systemic solution for the energy retrofit and the upgrade of residential, commercial, and public buildings. The system's special configuration and the flexibility make it suitable for application all over Europe. In our case, we are just starting our pilot. We identified the public building, which is now used by local associations committed in social issues. In these days, we aim at starting works. All the administrative procedures have been done, all the studies, the project. So we think we can start next week the demo site. What we are doing in the Reskin project, no scaffolding installation. Use of scaffolding is replaced by that of a moving platform. Most of the wiring and on-site devices are avoided. Specific components allow partial reuse of the existing windows. And works can be done from inside. This is very specific action of Reskin. The works are really light. We are going to regenerate, to make this building more efficient with very, very light works. And according to studies, it will reduce the energy consumption by minus 80%. Share of circular materials on the total, estimated for 4 case studies, amounts to 59%. We will receive the materials from another part of the project, so we are talking about a really, really innovative projects. I said before, we started with Google, and I guess now all technical aspects change a lot. So we're working on this since almost 15 years. We are glad of the experience we did. And we recognize European projects, in this case FP7, Horizon 2020, Horizon Europe, are a great opportunity for local authorities to get significant and tangible improvements on the topic of energy-saving public buildings. We have a lot of lessons learned. The development of partnerships are really important because they make it easier for public bodies to team up with excellent scientific partners, in our case Politecnico of Milano, but not only, and to exchange good practice with other public bodies around Europe. We learn a lot from other European cities. Our colleagues are traveling thanks to this the opportunity given by the project in other cities, seeing what other public administrations are doing. This is supporting us in the internal management. The projects provide ideas on how to better organize the work within the public body, and I assure you this is really tough because in a big public body like the Municipality of Milano with almost 15,000 employees has a really, really complicated administration and has a really, really complicated bureaucracy issues, and this is really of support. Social aspect, last but not least, as I said before, these projects, technical projects, help us improving the conditions for citizens living in public residential buildings, because at the end, the main target of these projects are people living in public housing. So they are the direct beneficiaries of the project. We learned a lot on these projects. I have to admit that for us it's really tough to implement these activities because Italian public administrations have a lot of administrative issues to develop before implementing a project like this. But the projects themselves helped us in reduce the time to develop these activities. So the City of Milano is on the front line on EU projects on this, and we build partnerships to develop new projects on energy and energy efficiency, and generally speaking on the topic of fighting climate change. If you have any question, thank you so much.
Thank you, Marco. Thank you very much. Yes, now it's the time for questions. It's the time for talking each other about those matters which are urgent. Who wants to break the ice with a question, with a statement also? Doesn't need to be a question. Curiosities also. No one? Too many figures?
Break the ice.
Please, yeah.
Just for an additional comment on the cooperation and on the fact that at least in Italy there is maybe not a good opinion on the working of the public authorities and the possibility for them to develop high quality work. I think that these cooperations that have been illustrated show how our public body can be an actor, and the cooperation with industry and with researchers is one of the things that we also appreciated, the fact that the availability of a public body to work on things that were challenging for them is really a great value in this difficult task we have. So that's just my comment on the fact that yes, we can do beautiful work in public areas with cooperation with industry. There is a lot to do for everyone, and yeah, in spite of some negative expectations that sometimes are running around in Italy, everyone is doing a beautiful job.
Please. Let's keep it on.
Yeah, thank you. Just regarding the community of Milano also, how has been your experience also in sharing these results and lessons learned with a community of other cities, and how has been this exchange of experiences to scale more the results of this type of projects and everything else? Have you been having this type of experience? How it has been for you in this sense?
Thank you so much. Well, actually, we are quite proud about all these experiences. It's almost 15 years we're working on this topic. Now it's quite common at city level. I think 15 years ago, very few cities. In Italy, really, really few cities were working on this. In Europe, okay, maybe Northern Europe, much better. We try to share our experience, not only to teach what we did, but mainly to learn from other cities. Possibilities like this are an example to see what our cities are doing. We are part of different networks of cities, for example, Eurocities, which is the biggest network of EU cities, where there is a specific, how do they call, kind of working group. They call working group. There's a specific working group on this, and we take advantage of this by learning and by sharing what we are doing. It's not easy. Because in different countries of Europe, there are different regulamentations concerning public building. It's not easy even at local level, because myself, Andrea, Lorenzo, we talked about public building, residential public building, but in Milano, residential public building are managed by two different authorities. One authority is the one managed by the municipality, which is the one we mainly manage to work, and there is another one managed by the region. Region and municipality, they do not have a good relationship, so we do not have very good access in working in residential public buildings of the region. So they have different rules, they work differently from us. So inside our municipality, there are a lot of problems. If scale up in Italy, we can multiply these problems. If we multiply in Europe, even more. But for us, it's really relevant to learn from other cities and to take advantage of EU projects. City of Milano is really committed on EU projects. Today, we are seeing few of them. We have today more than 40 European projects developing, ongoing today, spanning from housing to culture to youth to whatever. And so we really believe that the EU projects are an opportunity for us to learn and to share what we are doing.
Thank you, Marco. Please, yeah.
Thank you. Yes, Claudia Vannucchi, European Institute for Energy Research, Germany. I was wondering if you had any figures about what would a large-scale rollout of your energy-efficient solutions in the buildings, what would that be the impact on the electricity grid and district heating and cooling network in Milan, if you had any thoughts about it? At least we have, within IFER, for a project, a demonstrator in Milan, and we're working with the electricity grid and the district heating and cooling network of the east side. And maybe, I mean, it is not the scope of this particular Horizon Europe project right now, so it's just taking care of the electricity network and district heating and cooling and see how they interact with each other, but maybe in the future, once you have a large-scale rollout of such buildings, they could be used as provision for flexibility as a, yeah, you mentioned the concept, so I don't know if you had any figures or idea of future development in that side.
Okay. As I said, we concentrated the first years on this specific area of the city, which is southeast, and now we are now working on larger space, larger area. We do not have, and this is actually a good idea, a study of the results, technical results of all these EU projects. We have results of each single project, but this could be a good idea to put everything together. The city of Milano, as said, we are part of the 100 cities, and we just developed the Climate City Contract. I don't know if you heard about that. It's an European initiative which is involving 100 cities. Among the 100, I think 8 or 9 are Italians, then from all around Europe. And the aim is to reach the climate neutrality by 2030. Honestly speaking, at least talking about Italy and Milano, it's impossible. So in our proposal, we explain that we are working on a kind of molecular strategy. So we would like to reach the climate neutrality by 2030 in some areas of the city. And we are now developing this kind of studies on these areas. This is one of them. And well, we do not have a comprehensive study of all or results of all these projects, but I think this is a good idea. We can work together with Lorenzo in doing a kind of publication of all results of these projects. And then when it's done, we will share with you. Thank you so much.
There are a number of buildings which are under retrofit on similar lines, so it would be really important now to put the pieces together. We need to exchange of plans. You are doing plans in your
Yes, basically, I mean, we have for this particular Horizon Europe project have a series of demo sites, and one of them is in Milan. And we're working with una rete H2020, RSC, Studio Consumatori, so the Italian partners is quite a solid consortium on the Italian pilot. And we're working with the Canavese power plant and with the district heating that is connected to it and the electricity grid. And basically what we're looking at is the flexibility that some interventions at the multi-energy system levels will have on the electricity and district heating grid, and how that can shape peak or reduce overall operational costs and generate revenues, so on and so forth. And at some point, buildings will need to be in the picture. So as of now, we're not looking at buildings. That is input data for us, their energy consumption. We're not really thinking about that. But at some point, if there is really a large-scale rollout of near zero energy building, then that impacts obviously also the flexibility that is needed at the distribution system already there. So it's nice to make the link at some point.
Absolutely. The system level is now the next step of integration that we have to work on. There are matters where we in general, we are aiming in that direction.
And it's, of course, even subsidized for public buildings. We didn't touch the costs matter, but we should not forget that we have conto termico, which is a fundamental financial instrument for public buildings. In fact, those mentioned projects benefited from conto termico, and possibly the most interesting and easy application of a PBD directive should be first in public building stock, because that's the way to make public storytelling learn that is not like blood rain, like in the Italian narration is often called, or who pays for that statement. The question should be who is now paying for that? Because this is the huge problem. People, especially low-income people, are now paying for not being thermally retrofitting their buildings. So this is a huge problem that has easy solutions, possibly, yeah.
That scheme is paid with part of the electric and gas tariff, so it's not public debt, it's not, so it's a sort of revolving fund from the energy used to the energy retrofit. So it's long term and it's ongoing in spite of all the issues that we have on keeping public debt under control, not willing to increase taxes to the high income population, then we have to find another ways to finance.
Any other? 3, 2, 1. And thank you very much.